Microwave bench impedance measurements series on microwave engineering, lecture number 6.16. Impedance is an important quantity in electrical engineering. It is complex and measured in ohms. Its real part represents resistance and the imaginary part representing reactance. Inverse of the impedance is admittance, measured in mhos or Siemens. Impedance is defined as the ratio of voltage to current in an AC circuit. The term impedance was coined for the first time by Heaviside, and Kennelly was the first person who used complex numbers to represent the impedance. At low frequencies, several methods, several instruments got developed to measure impedance. But the underlying principle of measurement at those frequencies, at low frequencies, is based on the concepts of voltage and currents. At high frequencies like microwave frequencies, voltages and currents are displaced by fields, electric field and magnetic field. Voltages and currents, they are not used, not at all useful. Hence, the techniques and instruments that are there to measure impedance at low frequencies, they cannot be used to measure impedance at microwave frequencies. New techniques got developed. In the present session, one such a technique to measure impedance is introduced, described, and explained in an elaborate manner along with the underlying mathematical principle. Now, let us move further to the course session. Let us begin with a few relations which are brought from transmission line theory. The impedance at high frequencies is found through indirect means from RC over the load. RC stands for reflection quotient. Reflection quotient over the load, it is indicated by gamma L. Reflection quotient is a complex quantity. It varies from point to point over the line. Over the load, it is indicated by gamma L. The load impedance and reflection quotient right over the load, these two are related. The relation is given by this formula. ZL stands for load impedance. Gamma L is reflection quotient over the load. The connection is given by this formula. Here Z0 is characteristic impedance of the line. This is the line, this is the load, this is ZL, Z0, here gamma L. The magnitude of RC reflection quotient is determined from SWR over the line. When the line is lossless, magnitude of reflection quotient can be found from the SWR over the line. Symbol for SWR is rho. This is magnitude of RC. The relation is gamma magnitude is equal to rho minus 1 by rho plus 1. Magnitude remains same over the line when the line is lossless. Magnitude of reflection quotient is same. Therefore, gamma L magnitude can be found from SWR using this relation, rho minus 1 by rho plus 1. Angle of RC, theta L, can be calculated from minimum shift method. In this method, it is found from the shift of any one minimum, D shift, when the load is replaced by a short. So, experimentally, D shift is determined and it is substituted here to find theta L. Of course, beta can be found from the basic fundamental or defining relation 2 pi by lambda g. Lambda g can be found from the bench. So beta can be found, D can be found, D shift can be found, theta L then can be determined. Once magnitude gamma L and theta L both are determined, one can substitute here and get load impedance. Now, what is this minimum shift? See, when ZL is different from Z0, what happens is reflections happen over the line, resulting in the formation of standing wave pattern. This is load. In the standing wave pattern, one can notice several minimum points, several maximum points. These are all maximum points. Now, if the load is replaced by a shorting plate, then the pattern shifts either towards source or towards load. The amount of shift can be measured by measuring the shift of a minimum. Let us say this minimum. When entire pattern shifts, the minimum in the pattern also shifts. Measure the shift of a minimum. How much it is shifted, that is D shift. From D shift, one can get theta L. Complete information pertaining the minimum shift method is being shown here in a block diagram or tree diagram. Load measurement, minimum shift method. ZL is equal to Z0 1 plus gamma L theta L I 1 minus gamma L theta L. Gamma L is magnitude, theta L is angle. Notice it is angle of reflection coefficient over the load. Gamma L magnitude can be found from rho minus 1 by rho plus 1. Rho is SWR. Theta L can be determined from 2 beta D shift minus pi. Now, direction of minimum shift on short. Minimum, particular minimum or shift of the pattern may be towards source or it may be towards load. Two possibilities are there. When pattern shifts towards source, minima also shift towards source. How much is the shift? This shift can be measured by measuring the shift of one minimum. If direction of minimum shift on short is towards source, polarity of minimum shift on short D shift polarity, you must give negative sign to it. Suppose 2 mm shift is there. So D shift becomes minus 2. Polarity of quotient phase theta L, it is positive. In such case, load type is inductive. When load is inductive, then shift is towards source. This is the conclusion one can come when we understand all these aspects, all the aspects that are mentioned here. When the shift is towards load, the shift should be considered as positive. Polarity of quotient phase angle theta, it becomes negative. It implies the load is capacitive. Here what is being told is two aspects. One aspect is polarity of D shift or sign of D shift. It should be considered as negative when the shift is towards source. When the shift is towards load, then D shift should be considered as positive quantity. This is one aspect. Second aspect, when the shift is towards the source, prima facie one can consider the load as inductive. The amount we may not be knowing right now, but one can conclude that the load is inductive. If the shift is towards load, then one can conclude that load is capacitive. Now the procedure. To measure the impedance, the bench is required to be terminated with the device under test DUT, for which impedance is to be measured. After necessary adjustments in the bench setup, the SWR row is found. In addition, the position of a minimum in the standing wave pattern is to be noted down when the bench still remains connected to the load. So actually it is a two-step process. Finding impedance by minimum shift method is a two-step. In the first step, the bench is terminated with the unknown load, DUT, device under test, for which we want the impedance. When the termination is impedance, unknown impedance, DUT, then we need to make two measurements. One is finding SWR. Another is noting down the position of a minimum in the standing wave pattern. Now, the terminating DUT is replaced with a short and the guide wavelength is then measured. In addition, the shift in the location of particular minimum that is noted in the previous step, both in magnitude and direction, is to be noted down. So in the second step, again, one has to make two measurements. Of course, in the second step, the termination is a short. Two measurements are, one is finding guide wavelength and the second measurement is finding the shift of the minimum that is identified in the first step. The search for this shift should be limited to a distance equal to lambda g by 4 on either side of the minimum position that was identified in the earlier step. If the shift is towards generator, then the load is inductive. If the shift is towards load, the load is capacitive. This information is from transmission line theory. This is the bench setup for measuring impedance. Source supply, isolator, flap attenuator, frequency meter. Frequency meter presence is not essential for measuring or in the measurement of impedance. If it is there, let it be there, but see that it is in detuned position. Now, output of frequency meter is then connected to standing wave detector, whose output is via tunable probe is given to VSWR. Standing wave detector is terminated over DUT first and then over short later. In the present experiment, the shifts of the nodes are measured with respect to their positions when load is connected. The directions of these shifts are naturally opposite when measured with respect to their positions when short is connected. Hence, when the load is connected and shifts are measured with respect to node positions under short termination, if the shift is towards load, load is inductive, and if it is capacitive, the shift is towards generator. So the point is this: sometimes one may perform this experiment with doing step 2 as step 1 and step 1 as step 2. There is nothing wrong in doing that, but while giving sign positive or negative to the shift, T shift, this particular aspect has to be taken into account appropriately. Precautions: both the source and attenuator should remain undisturbed so that wave is at the same power level and same frequency in the standing wave detector until completion of the experiment. For better accuracy, distances between several successive minima may be noted and their average be considered to calculate guide wavelength. So this is standing wave pattern. What we need is VSWR or SWR rho. If SWR is small, less than 10, low VSWR method, it has to be used. If SWR is more than 10, then double minimum method has to be followed. So by following appropriate procedure, rho has to be determined when termination is DUT. In addition to determination of SWR, one has to identify a minimum, a particular minimum. Let us say this minimum. It is identified and its location is noted down. Scale is there. With the help of the scale, its position can be noted down. Now DUT has to be replaced by shorting plate. With the shorting plate as termination, two measurements are required to be made. One measurement is guide wavelength, lambda g. How to find guide wavelength? Measure the distance between any consecutive minima. This is one minima, this is another minima. Of course, the pattern is not going to be same when you replace DUT with SC. Let us say with the SC termination, this is the pattern. Now measure the distance between two consecutive. It is lambda g by 2. Multiply it with 2, it gives you lambda g. To increase the level of accuracy, what he is telling is measure the distance between several consecutive minima. For example, these two measure, these two also measure, between these two also measure, between these two. Take average and then multiply it with 2. That gives you guide wavelength. This is one aspect. Second aspect is you have identified a particular minimum in the first part of the procedure. Now, in the second part, what you have to do is search for this minimum, search for a minimum, source side, as well as load side, a distance of lambda g by 4. Lambda g by 4 this side, lambda g by 4 this side. You search for a minute. You can search. If you search, you can find. You can find either source side or load side. You can find that minimum. Don't search beyond lambda g by 4 on either side. Search should be limited to lambda g by 4 on either side. You find. Now note down. If you find the minimum this side, load side, measure the distance, reshift, and give appropriate sign to it. You may find the minimum on the source side to somewhere here. Then measure the distance and give appropriate sign to it. Now, after completing the experimental procedure, you can calculate the impedance either by analytical means or by using a Smith chart. First, we consider analytical means of finding impedance. ZL is Z0 1 plus gamma L by 1 minus gamma L. This is basic formula. In fact, this is the one that has been introduced to you in the beginning of the session. So Z0 is normally known, available. So you need to do nothing about it. Gamma L is known, then substitution gives us ZL. Gamma L has magnitude and angle. Magnitude can be determined from SWR. The angle, it can be determined from this relation minus pi plus 2 beta d shift. What is this relation? This relation is from the properties of standing wave pattern over a lossless line. First minimum in the pattern from the load. It exists at a particular distance from the load. This distance depends upon the load. If the load is inductive, first minimum exists at one distance. If the load is capacitive, distance of the first minimum different. Even when the load is inductive, different amounts of inductive loads give different amounts of distances to the first minimum. Same is the case with capacitive loads. So location or distance of first minimum, it is an indication. It gives a lot of information pertaining to the load or type of load. So this relation has come from the connection between type of load and distance of first minimum from the load in the standing wave pattern. D shift is dl minus ds, shift in reference minimum when shorted. Minimum shift towards load happens, then D shift is negative, load is capacitive. When minimum shift is towards generator, D shift is positive, load is inductive. One can determine impedance using Smith chart too. With the measured SWR, draw constant SWR circle over the Smith chart. So this is constant SWR circle. Center of the chart as a center and rho as a radius. Center to rho, here is rho, center to rho value as radius. Draw a circle, it is called constant SWR circle. Locate V minimum point, that is the intersection of horizontal axis and SWR circle on the left side of center of the chart. So this is V minimum. From this point, move an angle psi equal to 2 into 360 degrees by lambda into D shift over SWR circle and locate load point. You see here, move, locate load point. The movement over the circle is clockwise. If the shift of minimum is towards load, it is anti-clockwise if the shift is towards the source. In B is depicted the situation when the shift is towards the source. Notice Smith chart gives normalized load impedance. To get load impedance, we have to multiply it with the characteristic impedance of the line or slotted section. These are some of the things which I can share with you for right now. To recap here, a method by which impedance is determined with the help of bench is given and described. Theoretical aspects as well as experimental procedures, both are described and discussed in detail. Enough for now. Hope you have a transformative and an insightful learning experience. See you again in another session very soon. Bye bye.